So we're on quadratic functions lesson 4, looking at equations and intercepts, and we're on page 317 in your workbooks. So the main goal of this particular lesson is to use what we know with the standard or vertex form, and given a vertex and a point that the graph goes through, that we should be able to write the actual equation itself. So they've given us a series of steps that we can look at, and the steps are actually a really good way to go about it. So what they say is, given that vertex, and we know that the vertex is in the form of PQ, so you can substitute P and Q into your general equation, and then because that graph goes through the point x, y, then we can replace x and y in our general equation with the point, the coordinates of the point that are given. You then have one variable left, which is a, which we can solve for, and then we can replace a, p, and q in the actual general form itself to come up with something more specific. So I'm just going to highlight all of this because this is a good way to go about working through your solution. So if we take a look at class example number 1, and it says that the graph of a quadratic function has vertex of -2, 8, and it passes through this particular point. So what do we know then is that P is equal to -2, Q is equal to 8, and in this particular case we're going to substitute in a general x is -1 and y is 7. So in this we can go ahead, so y is 7 and a we don't know, x in this case is -1 minus -2 all squared and plus q, so plus 8. So let's clean this all up then. So we have, I can move the 8 over, so we're looking at negative, whoops, so subtracting 8 from each side, so -1 is equal to a, and then -1 minus -2 is the same as -1 plus 2, which is 1, of course. 1 squared is just 1, so then a is equal to -1. So now that we know a is equal to -1, we're just going to substitute in a, p, and q. So in that general form, y is equal to a times x minus p all squared plus q. I'm going to leave y and x as just general y and x so that I could find any other point if I wanted to. So that means that y is equal to -1 times x minus -2, so again, this time I'll put in minus and negative is the same as plus 2 squared, and then plus 8. So that is our equation in standard form or in vertex form. So what we can see from here is that if we wanted to graph this equation, even before putting it into our calculators, because I can see that the question asks you to graph it in part C, but let's just go ahead and try this on our own. So if we know that the vertex is going to be at -2, 8, so let's go to -2 and 8, so 6, 7, 8, so it should be right about here. Oops, is my vertex then. And then because the stretch factor is just 1, it's not actually stretching, but it is -1 is my a value, which means that it's reflected, so it opens down. And so since there's no stretch factor other than 1, we can just do our standard, which is 1 across and 1 down. Axis of symmetry allows me to essentially plot 2 points at once, and then 2 over and 4 down, and 3 over and 9 down. So that should put us right there, right here. So I can go ahead with those points and sketch my graph then. Okay. Great. So rewriting it into general form means taking y equals -1 times x plus 2 all squared plus 8. And since we want it in ax squared plus bx plus c, you can see there's no brackets there. So essentially what have they done is they have expanded that. So we want to expand x plus 2 times x plus 2. So that means that we're looking at y is equal to, if you want to, and the start right now is just to expand that, go ahead. If you can do FOIL without that being expanded, that works as well. Remember that it's a binomial times a binomial, which means that it's going to equal a trinomial. The only time a binomial times a binomial equals a binomial is with a difference of squares, and this is definitely not a difference of squares. As well, exponents come before multiplication. That means that you don't want to distribute the negative in first. So let's do the expansion of these two binomials. So that is y is equal to -1 times x squared plus 2x plus 2x, which is x plus 4x, and then plus 4, then plus 8. Now I want to distribute the negative, so y is equal to -x squared minus 4x minus 4 plus 8, and clean that up one final time. So y is equal to -x squared minus 4x plus 4. And so that is the equation written in general form. So if we are going to draw the graph, then conceivably, because these are equivalent, it's just one is expanded and simplified in that way, the other one is in vertex form. We should be able to enter either of these into our calculator and hopefully come up with the same graph that we have sketched on our own. So let's do that first. So I'll start with the vertex form. And so if you enter that in, there that is negative of x plus 2 all squared plus 8. And you can see that that looks similar to what we have. The reason why this one on this calculator looks wider than the one that is up here, so if I put them side by side, it's just because of the spacing. You can see here along my x-axis it appears to be spaced a little bit more, so it gives us a little bit of a distorted view. If we enter in the second one in y2, let's take a look at what happens there. So if we go to y equals and the second one, so that will be then -x squared minus 4x plus 4. And let's bring that over here and graph. And we should see, yep, it comes exactly right over top of my original, which is a good confirmation that I've done a good job expanding that and simplifying that then. So why is it then that we have two forms of the same thing? On the one hand, lots of people like their general form. Why do you like the general form? Well, it looks a lot cleaner. There's no brackets. The exponent's already been applied, and so people like that form. As well, what you'll see is it's going to be very easy at that point to determine what your y-intercept is. Versus when we look at this other form, well, hopefully it's becoming obvious to you why it is that we like vertex form, and that is simply because it gives us so much information that allows us to graph it. From here we can tell what the shape of the graph is. We can tell what the vertex is. Is it opening up? Is it opening down? Is it stretched? What's the axis of symmetry? What's the min or the max? So all of that information then is within that standard or vertex form, so which is why we like that one. Okay, so let's take a look going back here. So we've sketched our graph. So it says determine the x and the y intercepts of the graph of the function. So remembering that, so what is always true when it comes to, we'll do the y-intercept first. So the y-intercept, what is always true at the y-intercept? The y-intercept is, of course, where the graph crosses the y-axis, is that x is equal to 0. So easy thing when we look at our equation, in particular when it's in general form, we can see that y is equal to, then it's going to be 0 minus 0 plus 4. So obviously the y-intercept, then I'll write that out right here, the y-intercept then is equal to 4. So that's something that is very, very simple to see. You don't necessarily want to go to your graph, specifically just right on the graph, because it may not be evident and clear. Remembering, I've said to you guys lots of times, just because it looks like it doesn't mean that it's necessarily true. At the same time, if we can pull up the table of values, I can see, hey, when x is 0, y is in fact 4. So in terms of the x-intercept, this is now where it's a little bit unclear, because we can see, what is clear though, is that it crosses not at an exact whole value at an integer point, but it crosses in between. So we need to be a little bit more exact with that. So at this point, we're just going to solve for that graphically using our calculators, and we'll go through other methods of how to solve for our x-intercepts algebraically later on. But what do we know is for your x-intercept, though, of course, y is equal to 0. So if we were to substitute in 0 is equal to negative x squared minus 4x plus 4, it's actually unclear exactly what x value is going to work for us. And again, when we look at the graph, it's not totally clear what that is. So let's use our calculator to solve that for us. So to use the calculator, remember we're going to second, and it's calculate. So not the trace button, but calculate, and we are looking for the 0. And the 0 is what gives us specifically the x-intercept. So we can go to 0, and what it's saying is the left bound. So because we have two x-intercepts here, then we need to know which one that we're trying to find. So if we want to find the one on the left, what we need to do is we need to move this cursor to the left of this intersection. So to the left of the intersection puts us somewhere down along this line, that bottom half. So let's move the cursor over. And there it goes. And so now we know that for sure we are to the left of this one. So it says left bound. Yep, that's our left boundary. So I'll hit enter. And now it's asking for the right boundary. So I want to go to the right of this x-intercept. And so that puts me anywhere over here. So I don't want to dip below this side, because the problem with it, if I was to put the right boundary over here, there's actually going to be two x-intercepts between my left and my right boundaries, and your calculator won't know which one you want, and so it's just going to guess and give you one of them. So you want to be more specific, so you can just move your cursor over, and now we are to the right of this x-intercept, so I can hit enter. And so you can see clearly here, there are my boundaries. My x-intercept is captured in between. It says, do you want us to take a guess? Absolutely. Hit enter. And so when y is 0, x is approximately negative 4.83. Negative 4 83 hundredths. So let's write that one down then. So our, whoops. Not sure what happened there. Let's fix that. So when writing this down, I'll just indicate right now that I'm using my graphic display calculator, the GDC, and so that's the x-intercept. The first one is -4 and 83 hundredths, rounded to the nearest hundredth. So let's take a look then for the other one. So if you want to try that process on your own and then come back, we can take a look at that. So once again, what you probably did, hopefully, is you did second trace, which is calculate, and we want to go to the 0, so the second one, in order to find the x-intercepts. So it says left boundary, so what I showed you last time was moving the cursor, because again, we want to find this x-intercept, so I need to be on the left of it. So I need to be somewhere above the x-axis in this particular case. So again, even just moving the cursor up from there, that would work. The other thing that you actually can do, it doesn't prompt you, but you can also enter in what the left boundary is. So I might say that the left boundary is -2. And you can see as soon as I start typing, it puts in that x is equal to -2 as my left boundary. So now it's saying, well, where do you want your right boundary? So again, I can just move the cursor. So right of this x-intercept is anywhere down here, but I know that, let's say, +3 is also to the right of that. And so I can also just enter in 3, and that takes that as the right boundary. So you can see clearly here my left and my right boundaries. The x-intercept that I want to capture is right between there. It says take a guess, and I will hit enter, and it provides me with the 0, that x-intercept, as rounded to the nearest hundredth, 83 hundredths then, and y is equal to 0. So let's write that in. So the other intercept is rounded to the nearest hundredth is 83 hundredths. I just want to go back to the calculator for a moment and show you a couple of things as well. What I don't want people to do, so if we were just looking at the graph, some students say, oh, you want the x-intercepts? Okay, and they just hit they think when I'm saying second calculate and 0, and you get the cursor, some of them are ignoring the fact that the calculator will do the work, and instead they're just moving the cursor themselves and hoping that they can get close to y equals 0 and then estimating from there. So they're just moving the cursor around. That is not what you want to do to find that exact value. So actually let it calculate for you. So when it asks you for that left boundary, then put in what that left boundary is, or move your cursor to the left boundary. So don't attempt to use trace in order to find what the intercept is. The other thing, we calculated the y-intercept algebraically by substituting in x equals 0. Your calculator can do that for you as well. So if you simply go to second calculate, calculate value means you input the x and it spits out the corresponding y value. So I want to calculate the value, so it's on there, and it prompts you, what do you want x to equal? I want x to be 0. That would give me my y-intercept, and then it clearly shows us that I can come over here, y is equal to 4. Good. So let's take a look at the next question then. So finding intercepts from the standard form. So again, let's take a look. So we can use the equation of a quadratic function to algebraically determine those intercepts. And so if we want the x and y intercepts, so again, let's start with the y-intercept, because that's the easiest one to do, because y is already isolated. So for the y-intercept, x is equal to 0, so that means that y, I can replace f of x, or we can replace f of x with y, and so that's 3 times 0 minus 1, or -1 squared minus 9. -1 squared is 1, so that's just 3 minus 9. So then our y-intercept is going to be -6. So the y-intercept then is -6. for my x-intercepts, then we know that y is equal to 0. So the x-intercept, y is equal to 0. So that means that f of x is actually 0. So we have 0 is equal to 3 times x minus 1 all squared minus 9. And so it's about isolating for x. I don't want to expand this at this point. We know if I expand it, I'm going to end up with an x squared and negative 2 x's. So that gives me two different x's, two different terms with x's. It's much better right now because I just have the x in one place. So in this particular case, then we'll add to isolate x. We want to move everything else from around it. So we'll add 9 to both sides. So 9 is equal to then 3 times x minus 1 all squared. We'll divide both sides by 3. So 3 is then equal to x minus 1 all squared. And then at this point, because it's squared, well, we will take the square root of each side. So that means that the square root of 3 is equal to x minus 1. Now, before we go any further, remember, when you take the square root, we have previously mostly only looked at the principal square root or the positive, but we know that with our quadratic, we're going to end up with two x-intercepts, and so we are looking at plus or minus root 3 is equal to x minus 1. And so then to isolate x for my x-intercept, I will add 1 to each side. So that tells me then that my x-intercept adding 1 to each side will be 1 plus or minus root 3. So those then are your two x-intercepts. In some cases, you'll see people writing both just together as 1 plus or minus root 3. Other people may ask you to write them separately. So my x-intercepts are 1 plus root 3 as well as 1 minus root 3. Okay, so let's take a look at class example number 3. It says given the graph of a quadratic function is shown, the maximum point is shown, and so we want the equation of the function in standard form. So standard form, of course, being vertex form again. The maximum point is, of course, always going to be the vertex. And so we know then that PQ is going to be negative 1 and 2, and they've also given to us a point, negative 3, 1. So that is our x and y. That will allow us to find our a values. So we've got negative 3 and 1. So my standard form is my vertex form, and that is written as y equals a times x minus p all squared plus q. So and take a moment to substitute the values of p, q, x, and y in to solve for a, and then replace a, p, and q to get your standard form. So hit pause and go through that process, please. Okay, so taking a look, we've put in y is 1, a is what we're trying to solve for, x is negative 3, p is negative 1, so when I subtract negative 1, it's the same as adding 1, all squared, and then plus q, so plus 2. So if we simplify, I'll subtract 2 from each side, and then negative 3 plus 1 is negative 2. The whole thing is squared, so negative 2 times negative 2, which is positive 4, and then divide both sides by 4, so a is equal to negative 1/4. When we put that into our equation with my p and my q values, which reflect the vertex, then we end up with the equation of the quadratic function in standard form or vertex form. So again, let's look at finding the x and y intercepts of the graph algebraically, and they want it both as exact values to the nearest hundredth. So that means that we might need to use our calculators afterwards to determine what those x-intercepts are to the nearest hundredth. So let's take a look. Y-intercept, again, is the easier one to do first. So for our y-intercept, x is equal to 0, so this point I have y is equal to -1/4, x is 0, so then it's just times 1 squared plus 2. 1 squared is of course 1, so then I'm just looking at y equal to -1/4 plus 2, which is then 1 3/4 then, or 1.75. Y is equal to 1.75. You could also write, of course, 7/4. So this would be to the nearest hundredth, and both are exact values. So there's my y-intercept. For my x-intercept, then we know that y is equal to 0. So again, take our vertex form, our standard form, set y equal to 0. So that's -1/4 times x plus 1 all squared plus 2. So then I will subtract 2 from each side. So -2 is equal to -1/4 divided by x plus 1 all squared. To isolate, I first need to get rid of that -1/4, so I will multiply both sides by -4. So multiply that by -4. We'll also multiply this side by -4. So that means that on the left side we'll have 8. The right side, -4 times -1/4 is then +1, so I'm left with just x plus 1 all squared, square root both sides. So then we have the square root of 8. Again, remember, as soon as I take the square root, we're looking at both the positive and the negative, and that is equal to x plus 1. And then we'll subtract 1 from each side. So then -1 plus or minus √8 is equal to x. Root 8 can be simplified. So if you remember, √8 is the same as √4 times √2, and √4 is of course 2, so 8 is the same as 2√2. So actually my x-intercepts then are equal to -1 plus √8, or sorry, simplified, plus 2√2, and -1 minus 2√2. So those are the exact values, and if I enter those into my calculator, then I can determine what they are to the nearest hundredth. So we can see when we've entered those into the calculator, -1 plus 2√2 is rounded to the nearest hundredth, 1.83, and -1 minus 2√2 is then going to be -3 83/100ths rounded to the nearest hundredth. So let's write those in then. So adding the positive ended up being 1.83, and the other one was -3 83/100ths. So those are your x-intercepts then. Okay. Of course, we can confirm that as well if we were to enter the graph into our graphing calculators, and we can also then confirm our y and our x-intercepts. Okay. So last piece is state domain and range and equation for the axis of symmetry. So the domain, because it covers all of the x-axis, and it doesn't have a context to it, then the domain is simply x is an element of the set of real numbers. For my range, we have a maximum. We are dealing with the y-axis, so it's a set of y values such that y must be less than or equal to, and the high point, the maximum point, is 2, so y is less than or equal to 2, and it still belongs to the set of real numbers. For the axis of symmetry, then we are looking for the equation for this vertical line, and since it passes through that p-value or the x-value of our vertex, then we know the equation for the axis of symmetry is x equals -1. Okay, please let me know if you have any questions and complete those assigned questions.